Hey Chem Fam, I'm Chelsea and welcome to the family, a space where we get to the heart of chemistry one level at a time. Let's dive in. So today we are going to discuss about atom. We will discuss what basically an atom is, okay, the very basics, and then our main focus will be to understand a very confusing topic, but actually it is very easy. I will try to explain it to you in the most easiest way possible, that is atomic mass unit. All right. So we are going to start by trying to build an atom, okay, and we will see what exactly it is. All right. So let's start. So what I will do, I'll first add a proton, okay, then I will add an electron. Can you keep checking me on the periodic table here in the square box at the center? It will show the element, okay, corresponding to that atom, okay? So what do you see? Hydrogen, isn't it? And it is a neutral atom of hydrogen. Okay, now let's try to add one more proton into it. Do you see check the periodic table? Now it says helium. The nucleus seems a little unstable, so let's add a neutron. Oh, now it's stable, right? Okay, then we will add a proton. Now it is a neutral atom. Can you see? Yes, a neutral helium atom. What did I do? What are the changes now? We added up an extra proton, we added a neutron and an electron to get a new atom that is a neutral helium atom, isn't it? Now let's keep adding. I will add one more proton. Can you see check the periodic table? Now it says lithium. It's an unstable. The nucleus seems to be unstable. Okay, and it's shown as a positive ion. Now I'm going to add a neutron here. Still says unstable. I will add one more neutron. Oh, it's stable now, isn't it? Okay, but it's still a positive ion, right? So I am going to add another electron. Oh, now it's neutral atom. So now we have a neutral lithium atom. What is the change? We added one more proton, we added few neutrons and electron. Now we have totally a different atom, that is lithium. We started off with hydrogen, right? Then we added protons and then we got and electrons and neutrons, and then we ended up getting helium, lithium, like that. Do you see that? So atom is basically the smallest unit of an element. Listen carefully. An atom is the smallest unit of an element that retains its chemical identity. Retains its chemical identity means that is the smallest unit which has an individuality of its own. Okay, it has a chemical identity of its own. You may say, how is it the smallest? There's electrons, protons, and neutrons. Yes, there are further small particles within the atom that we do see. But the problem is, see, if I an individual electron is not special. It's not having a unique identity. Whereas a certain combination of electrons, protons, and neutrons make an atom, and that particular atom has a unique chemical identity of its own. Okay, so that's why we say an atom is the smallest unit of an element that retains its chemical identity and can take part in a chemical reaction. So here, even a hydrogen atom had proton and electron, isn't it? Even a lithium atom has proton and electron in it. But how do they differ? In the permutation combination of the number of electrons and number of protons and neutrons. So for a given number of protons, neutrons, and electrons, that combined combination of to form an atom, that is the smallest unit of an element which has a unique chemical identity such that it can take part in a chemical reaction. All right. Now let's go and see what the definition is. I'm going to again explain it with another analogy. All right. Okay. So again, I repeat the definition that an atom is the smallest unit of an element that retains its chemical identity and can take part in a chemical reaction. So now, if we want to relate it to a real life example, let's just consider a brick. When we have a big wall, okay, on a building, okay, of a building, so the bricks are the smallest unit of that wall, okay, just like the atoms are the smallest unit of an element. Now, you may say, just like in an atom, we can also have even further small particles like protons, electrons, neutrons. So why do we say the atom the smallest? See, even the brick, a single brick, what you have, you can dismantle it and powder it and like turn it into very fine particle, right? But then that doesn't build up the wall. You need a entity, a brick, and then you using those bricks, you end up building a wall, right? In a similar way, that entire combination of electron, proton, and neutron based on the certain numbers, each combination leads to an atom of a certain element. That atom itself has a unique chemical identity, and that is the smallest unit of an element having a unique chemical identity which can take part in a chemical reaction. So an atom is just like a brick which forms a big wall. It is the smallest unit that builds up the bigger entities. All right. Okay, I hope you understood. Now let's move on. Okay, so if this is what atom is, how do they exist in nature? Okay, so there are three ways in which atoms can exist. Either they exist in free state. Free state means as single atoms. For example, in noble gases like helium, neon, argon, these exist as single atoms, all right, in free state, all right. Whereas some atoms may exist in combined forms, okay, like say chlorine molecule. So chlorine will exist as two chlorine atoms will join together and exist as in a combined form. Say if this is chlorine and this is chlorine, they combine and stay together, stick together, okay. Or maybe an entity like methane with a formula CH4, they in which one carbon and four hydrogen come together and stay in combined form. So there are, this is an atom, this is also an atom, this is also an atom, this is also an atom, and this is also an atom. Or there are five atoms, okay, four hydrogen atoms and one carbon atom. But then how they are existing, not independently like helium, neon, or argon, but in a combined form. All right, about which a lot of details are there, which we will learn in the upcoming video. Or I'm sure you would have watched the first video of this level of the spiral. So there we started off with an experiment, right? There was an experiment to understand the law of conservation of mass, right? There, one of our product for the reaction was what? Sodium chloride. Remember, with a formula NaCl. So this exists as ions, like as Na positive ion and Cl minus ion in aqueous solution. So that is a third way of existing of atom. Okay, so this is a sodium ion, okay, and this is a chloride ion. So they exist as ions in aqueous solution, about which the details will be explained in the next video. All right, so basically atoms, how do they exist in nature? Either as free states or in combined form or as ions. All right, now we will come to the heart of this topic, that is the atomic mass unit, a very very important, very very basic topic. Okay, so you know what, atoms are very small, so small that they say one atom of hydrogen weighs around 1.673 into 10 to the power minus 24 grams. So can you imagine how small this quantity is? So can we weigh, does that even make any sense to weigh atom in kilograms? Not at all. Even in grams, makes it's very inconvenient to use these figures in exponents form. Can you see it's 10 power minus 24 grams? It's so small. So therefore, for our convenience, and since it's so small, even so, therefore we are going to use a new unit that is called atomic mass unit. So what we are going to do for this is we are going to fix one atom as what? Reference. Okay, and based on that we are going to calculate the masses of the atoms of other elements. So what is our reference here? It will be a carbon 12 atom. There is something known as isotopes, okay, about which we will again learn in the coming videos. So there is one isotope of carbon called carbon 12 with its mass number as 12. So we take the carbon 12 isotope as the reference. This is our reference, okay. So we use that as a reference and set the mass of the rest of the atoms of the other elements. All right, so how is this all happening? So to make you understand this in the simplest way possible, we are going to compare it to a watermelon. So just consider that one atom of carbon 12 is a watermelon, okay. Now suppose I divide this watermelon into 12 equal parts. Do we have 12 equal parts here? Let's count. Okay, so here it is 1 2 3 4 5 6 7 8 9 10 11 and 12, isn't it? There are 12 parts. Now out of this 12 parts, if I divide this watermelon into 12 equal parts and I take one slice out of it, okay, that is exactly what one atomic mass unit is. That is exactly what one atomic mass unit is. So if just like the way I slice the watermelon, if suppose I divide one atom of carbon 12 into 12 equal parts, and if I remove one piece out of it, okay, the mass of that small slice out of the 12 slices is one atomic unit, or 1U, which is the more latest format of writing, that is the unified mass. According to what? According to IUPAC. All right. All right. So what is 1 AMU or 1U? It is the mass of 1/12 to the mass of carbon 12 isotope. So if you have a carbon atom, you divide it into 12 equal parts and take one slice out of it. Whatever the mass of that 1/12 means, whatever the mass of that small slice is, that is 1 U. Of which atom? Of 112. That is the reference. That is the reference. All right. Now we will Now we will see what atomic mass of an element is. So atomic mass of an element is the number of times an atom of that element is heavier than 1/12 of the mass of an atom of carbon. Now that we have fixed a reference, we know what 1 U is. Now we need to know the atomic masses of the elements. So what is 1 U? 1 U is what? 1 U is whatever is the mass of 1/12 of carbon 12, right? So how many times your atom is to this particular mass is the atomic mass of any given element. Let's see the example, then it will become even more clear for you. Okay. So you see, when I say that hydrogen has an atomic mass of 1 U, that means an atom of hydrogen weighs exactly equal to 1/12 of carbon 12 isotope. All right, exactly equal to 1/12 of carbon 12 isotope. If when I say hydrogen is having an atomic mass of 16 U, that means the mass of one atom of oxygen is 16 times that one slice of carbon 12 atom, right? When I say the atomic mass of calcium is 40 U, that means one atom of calcium is 40 times the 1/12 of carbon 12. Okay, so the atomic mass of an element is the number of times an atom of that element is heavier than 1/12 of the mass of an atom of carbon 12 isotope. All right. So now here's the concept challenge for you. You are going to solve this question and drop the answer in the comment section. Let's see who is able to solve this. So the question is, if the reference standard for atomic mass was changed from 1/12 of a carbon 12 atom to 1/6 of a carbon 12 atom, what would happen to the numerical value of the atomic mass of oxygen? Currently it is 16. Oh, wonderful question. So there's a hint for you all here. Try to figure out the answer and drop it in the comment section. So see you in the next video.